This video discusses potentiometers. Potentiometers are resistors with three terminals, terminals A, B, and C. So this is a large power potentiometer here. And so as you can see, it has the three terminals. And between the two outer terminals, terminal A and B, it's just one constant resistance. So that resistance never changes. But then between the wiper blade, the center one, B, that one is variable. So the total resistance from A to C is basically the resistance of the potentiometer. So when you buy the potentiometer, you might get a 1 kilo ohm potentiometer or 5 kilo ohm potentiometer. And so that is the resistance between A and B. And then you can vary the actual resistance. So using this knob, you can then go in and vary that resistance. All right, so if we look at the side of this potentiometer, we can see that it's actually rated for 750 ohms, and it also has a maximum current rating, which of course is related to the power on there. So we have this knob, so we can adjust this knob, and when we do that, it adjusts this wiper on the back side. So you can see here that we have the two outer terminals, which are just fastened to the two outer portions of the resistance, and then we have the center is attached then to the center terminal is attached to the wiper. And so as I adjust the knob, so as I adjust this knob here, the wiper moves, and that then changes the resistance between the center and the left terminal, and it also at the same time is changing the resistance between the center and the right. And so effectively the total resistance, in this case 750 ohms, is being split. If we go between this left terminal and the center terminal, we're going to get part of that. And then if we go from that terminal to the other, we're going to get the other part. And you can adjust this from fully all the way over to this side where there would be zero resistance between the center and the left, and 750 ohms on the other side. Or we can crank it all the way the other way, so we have 750 ohms between these two terminals and zero between the middle and the right terminal. And these potentiometers are used in a lot of different applications. They're basically used to control the voltage, so that you're adjusting the voltage on here. So like if we look at this example, we have the circuit here. Say we have a 10 volt battery, and if we put the wiper blade directly in the center, then we would have a simple divider circuit. So we would have half of the resistance on top and half on the bottom, which would give us 5 volts. That would give us 5 volts right here at the terminal B when we measured that. However, that doesn't really give us a whole lot at that point, because we need to connect a circuit, a resistor or something to that. So we would put in a load resistor. And so applying a load resistor here now, we can adjust the voltage to the load, which will of course just how much current is going to flow through the load and therefore how much power we're getting to the load. All right, so this is a very cheap and easy way to control the current and or the power that we're supplying to some load. So one use of this would be for controlling the speed of a DC motor. DC motors, as you increase the voltage, you can increase the speed of the motor. So by using a potentiometer, we can control the speed of that. Nowadays, usually we use electronics because the one issue with this is it's kind of lossy, because remember, resistors are turning electrical power into heat, thermal power, and so therefore, this type of circuit, even though it's simple and easy to set up and use, it is kind of lossy as far as so some of the power is going to be lost within the potentiometer. Another use is for volume control, for stereos or whatever. Potentiometers are great for that because we can control the voltage into the amplifier by adjusting the potentiometer and therefore control the actual sound levels. So when we have a potentiometer and we connect it up to a load resistor as shown here on the diagram, then we end up loading the resistor. So as I was showing before, like at terminal B, without the load resistor attached, if you set the voltage at terminal B to be 5 volts, then you attach the load resistance. Well, now you have the load resistance is in parallel with the resistance between terminal B and terminal C. And so you have this parallel resistance, which reduces the overall resistance, and therefore you end up getting a larger voltage drop from A to B than you were getting before. So that's what we refer to as loading. So in general, if you want to minimize loading, you want to keep your load resistor to be much larger. They usually use the term much larger. Just a rule of thumb of much larger would be about 100 times. So you would want RL to be about 100 times larger than R1, what they have marked as R1 in here, which is the resistance between B and C. And that then it would still be loading it, but it would have a small loading effect. If RL was the same as R1, then it would basically be dropping that resistance. The parallel equivalent resistance would be half, and so that would be a major load change to this circuit. All right, so here we have the multi-sim software, and I already have part of a circuit set up here, but I want to add in a potentiometer. So I'm going to come over here and do a place basic. And when I do that, I can select lots of different basic elements. And down near the bottom, we have something called a variable resistor. And when you look at this, this is a 2-terminal resistor, which we can place into the circuit, and then as we run the simulation, we can vary this resistance and see how the circuit changes. Okay, but this is not really a true potentiometer here because it doesn't give us the center terminal to tap into. So effectively, this is like a potentiometer, but you're only connected between terminal B and C, and they don't give us access to terminal A, is effectively what's happening if you select this resistor. So if you come on down a little bit lower, you see that yes, there is a potentiometer with 3 terminals. And so I'm going to take and select that one, and I'm going to paste it in here, and then select close to close this. Now notice it gives us the total resistance, which is going to be between terminal A up here and terminal C down here, is 1 kilo ohm. Okay, but if we click on that, we can go into value and we can change that. So if I wanted to make it like 750 or whatever, like we had before on the big power one, we can do that. Also notice it tells us here that by default they set this to 50%, but we can slide this. Even when we're in the simulation mode, we'll be able to change this. Now it's telling us press key A. So if you press key A, you can change it by pressing that key. So if you have multiple potentiometers, you can assign them to different keys. Now to go up, I just press the key. To go back, I press shift key and it'll go back in the opposite direction. But that's what that key is just talking about. It's just telling us how to adjust it. So when we're running in the simulation and we got multiple potentiometers, we can change those. Now, right now the terminal is on the left, so I'm going to click on this right on the whole object and select the whole object. I'm going to right click and I can either rotate this, or in my case I want to flip it horizontally to get the terminal over to the right, because typically when we draw circuits we have the middle B terminal of the potentiometer over here to the right. So I'm going to take this and I'm going to connect this over to my 1K, and then I'm going to connect this down to the bottom, and then we'll connect this over here. And I also have a meter here. I just already had this in here, so I want to just measure the voltage between A and B. And then I also have a voltage probe here. It's kind of nice with the simulation software to just go ahead and put probes everywhere so we can measure these voltages, and we can measure the currents. So we can take and measure the current right here, and we can measure the current here, and just see what all is happening. Now remember, I am measuring the current here, which of course is the same as the current up here. And so I'll go ahead and just run the simulation here now. And you can see that, of course, we have 10 volts being supplied over here. And it's got 13.7 milliamps coming out of the battery. So, of course, down here is also 13.7 milliamps. And I guess I left this set at 20%. So that's giving me like 1.79 volts from terminal B to ground, which of course then leaves me at like 8.2 volts, 8.214 if you take it out that many digits between terminal A up here and terminal B. So if we adjust this now, again, I can adjust it by either using my mouse and run the slider, or I can use, it's telling me here I can just press on the A key. So if I set this to 50%, I get 4 volts. Now let me stop the simulation once. I'm going to break this connection right here. Okay, and I'm going to run this, and actually I want to put my voltmeter on the, I want my voltmeter going to B, okay, and so if I put my thing here, this is at 50%, I've got 10 volts across the entire potentiometer, and it's set right in the center, so that means I have 5 volts between terminal A and terminal B. And then, of course, if I was to put another one, I would have another 5 volts going to the other side. All right. But now if I then connect in this 1K resistance here, and I run this, you can see that the resistance at terminal B to ground, instead of being 5 volts now, it has dropped down to 4.21 volts. So that's what we're talking about when we talk about loading the potentiometer. So once we connect to that center terminal, we can set the voltage of the terminal with nothing connected, but that voltage is going to change because our circuit has now changed, because we have this resistor R4 is in parallel with the resistance from terminal B here to terminal C, this side down here. And so that's loading. However, if I stop the simulation once, now remember this is 750 ohms, and we're at 50% of that. So at 50% of that means that it's going to be 375 ohms. So just to kind of look at it, let's say that we set this to 375 ohms. So what that is saying is that R4 is the exact same resistance as the resistance from terminal B down to terminal C. And so when we do that, then, all right, this is going to be 1/2 of that resistance, which is going to be 187.5 ohms. But the resistance from A to B is also 375. So this is going to be this resistance between A to B is 375 ohms, but the parallel equivalent resistance between R4 and this lower half of the potentiometer is only half of that. And so I'm going to see the voltage is going to be about 1/3 of my 10 volts. So if we simulate this, right, we'll see that my voltage here is 3.3 volts. Right, so that's a heavily loaded potentiometer. Now again, as we can change that voltage, as we as we adjust this resistance, we can change that voltage. So if we adjust it all the way up so that the B terminal is all the way connected to the A terminal, I can actually get my full 10 volts across this R4. And of course, if I go all the other way, then there's no voltage. It says 1 microvolt, right? Just a tiny bit of voltage across R4, the load. So essentially nothing there. And then of course we can go to right in the center or anywhere in between there. All right. So, but again, at 50%, we're only getting 1/3 of our supply voltage over to our load resistance. So now let's go ahead and look at making the load resistor R4 10 times the RBC resistance. Okay, and so when we see that, and our potentiometer is at 50% still, so we know it's 375 ohms, you can see that we're, the voltage increased quite a bit, but it's still about 20.24 volts away from the 50% or 5 volt mark that it would be without the resistance attached. And then if we increase it a little bit, increase it by another factor of 10. So now this is that factor of 100 I mentioned earlier. So the resistance between terminal B and terminal C inside this potentiometer right here, this resistance, we're at 50%, so this resistance is 375 ohms. So I've made my load resistance 100 times that. And so if we do that, you see it's at 4.98 volts. So that was that rule of thumb I was talking about when when your load resistance is 100, a factor of 100 times more than your potentiometer resistance, then you have some loading. Yes, it's not exactly 5, but the loading is very small and can maybe be ignored. So that, the larger the load resistance is, the less it will load the potentiometer and affect this voltage at the center terminal.